Hi everyone, welcome back. In this video we will see what is ontology of engineering. Have you ever wondered how intelligent engineering system understands the connection between various components like machine, sensor and process? So this is where the ontology of engineering comes in. So what is ontology? The ontology is a structured way of organizing the knowledge in engineering. It defines concept, relationship, properties and the hierarchy between engineering elements. So if you simply take an example, let us take the solar energy system as an example here. A solar energy generates the electricity. So the battery stores the electricity, then the inverter converts the DC power into a AC power. This AC power is used in home applications. So here in ontology, these components and their relationships are connected systematically so that both humans and computers can understand the entire behavior of the system. So this is the ontology representation of solar energy system. We have solar panel, battery, inverter and AC load. So the electricity is being circulated into various components of this system. So this will give a complete relationship about the main component and the associated relationship between each and every components. In engineering and computer science, the ontology can be divided into two important categories. One is a reference ontology, another one is a application ontology. So both help to organize the knowledge, but they are serve different purposes. This is a reference ontology. The reference ontology is a very general and reusable knowledge model. So it provides the common concept, definition, standards, and relationship that can be shared across a multiple system and applications. So it's just like act like a foundation or a universal framework. So I'll show you the example of reference ontology. So here, if you look at the reference ontology, in this system, you can see different sensors, controller, actuators, and the physical quantity which you want to measure using a sensor. So these concepts are general and it is reusable for many applications. So here we have not given specific about the sensors, what type of sensor we are using, what type of controller we are using, what type of actuator we are using. So it's a very general concept and it is a reusable and a broad use model. It is specifically used as a domain level model. Now, if you're coming to the reference ontology is a standardized knowledge representation and reusability and interoperability between system and domain level understanding. So this is basically used in creating a common engineering vocabulary. For example, in application ontology is a specialized ontology developed for a specific application or a project. So here it uses the basic concept from the reference ontology and customize them for a particular application or a particular system. So if you take the example, it's a conveyor sorting system. In conveyor sorting system, we are going to sort the object which is coming on the conveyor. For this, we are going to use IR sensor. The IR sensor basically used to sense or detect the object. So once object is detected, this controller we are going to use Arduino Uno. So you'll be specifically giving what type of controller you are going to use for a sorting application. So using Arduino Uno, we are going to give a control signal to the servo motor. The servo motor will actuate the mechanism. This mechanism will move the object from the conveyor belt. So this is a way we are going to implement a sorting system with the help of all specific components. The components like a sensor, controller and the actuators, whatever we required for developing a conveyor sorting system, it is a specific components, right? So here the application ontology is a problem oriented approach and it is a very specific application oriented ontology. So in this diagram, we can easily compare the reference ontology and application ontology. So on the left side, you can see the reference ontology system. The reference ontology represents a general model that can be reused across a multiple system. So it defines a common concept such as what type of system you are going to use, a sensor, a controller and actuator. So these concept forms a standard framework for engineering application. So if you look at the reference ontology mainly focuses on defining the concept, establishing a standard relationship and creating a reusable knowledge. It is widely used in various applications like robotics, CNC machining, industrial automation and smart manufacturing system. So this makes it very easier for different systems to communicate using a common engineering language. So application ontology on the right side, if you see, the application ontology is developed for a specific problem. So here the general concepts are being converted into a real implementation component. So here the sensor is converted into a real component as a IR sensor. Here if you see, the controller is converted as a real controller, Arduino Uno, and the actuator is converted into a servo motor, and we are going to use it for sorting a sorting gate for sorting the object from the conveyor. So here the application ontology mainly focuses on real-time components and custom implementation and also problem-specific rules. So in this example, you would have learned this ontology is designed for a conveyor sorting system, and it helps to define how each components are interact within the actual application. So the reference ontology provides a general foundation, whereas the application ontology builds a practical engineering solution using that foundation. So in simple words, I can conclude the reference ontology is a blueprint language, right? While the application ontology is an actual constructed system. In engineering system design, two important concepts are there. One is functional model, another one is a capability model. In this model helps the engineers to understand what the system does and how well it performs. So in functional model, defines the behavior and operation of a particular system. In simple words, you can say that it explains what the system is designed to do. Okay. For example, the core functions which I have listed here, like monitoring, measuring, controlling, transporting, energy conversion, decision making, and feedback regulation. So these are some of the core functions of the system. So these functions represent the main activities which need to be performed by the engineering systems. So if you take the real example, in an automatic conveyor system, so sensor basically monitors the object, and controller makes a decision, motor transport the material, and feedback system regulates the operation. So all these actions are belongs to the functional model. Right. Now coming to the capability model, the capability model defines the quality and performance levels of the system. So it mainly deals with only the quality and the performance level. So it describes how efficiently the system performs and its functions. Okay. Now, these are the important or major capabilities are included: the accuracy, precision, repeatability, reliability, efficiency, response time, and throughput. So these characteristics basically determines the overall performance of the engineering system. Okay, so if you take the real example again, a robot may perform a pick and place function, but its functional capabilities mainly depends on how accurately the movement is there, and how fast the robot responds, and how reliable it repeats the operation. So these characteristics and performance we need to take it into account as a capability model, right? So if you see the relationship between the functional model and the capability model, the functional model says that what does the system do, and the capability model answers how well does the system can perform. So together these models helps the engineering design is more intelligent, efficient, and reliable system. So if you summarize this one, a functional model defines a system behavior, while the capability model defines a system performance and quality. But both are essential in modern engineering design, automation, robotics, and smart manufacturing system. A source of ontology model is a method used to organize a large ontology into a small or a smaller manageable submodules. For each module, it can handle a specific type of knowledge within a system. So this basically makes the complex engineering knowledge easier to understand, maintain, and reuse. So if you can ask why these ontology models are needed, right? So in large engineering system, a single ontology can become very complex. So to solve this problem, the ontology is divided into a separate model. So each model focuses on one domain or a functionality. So while we are doing this type of approach, this improves the clarity, scalability, and also a proper system organization. So if you simply take a proper understanding about what is the source of ontology model, so if you take one huge book, okay, which contain everything, knowledge is divided into chapters. So the reference ontology represents a complete organized knowledge, while the suits of ontology model represents the individual chapters. We'll see one example for reference and application ontology. In reference ontology, we are going to give only the system components like a sensors, controller, actuator. We are not going to give any specific component of this particular system, right? So here the concept model which consists of sensor, system, controller, actuator, object, material, signal, feedback. But if you look at the relationship model, how a relationship means how these systems are get interconnected and how it communicate with each other. If you take sensor, the sensor basically used for detecting the object, and also it measures the physical quantities, and controller basically process the sensor signal, and controller sensor processed signal or a control signal to the actuator. The actuator controls the material flow and the feedback that improves the overall system accuracy. So if you look at the picture here, it is a closed loop control. The reference input element is given to the as a reference input to your system, and here you have a control element, control system, and here we'll be having a feedback. So this output variable, we are not given any what specific application we are going to use in this particular system. It's a generalized system. This generalized system can be used for any applications. It's a closed loop system, right? So in reference ontology, the functional model says what it does, and capability model shows what the behavior as well as the performance of the system, right? So functional model basically you can monitor the system or measuring some parameters, controlling the system or transporting the material from one location to another location, like bottle filling. We're going to fill some chemicals or water, like that we are going to use a functional model. When coming to the capability model, it just shows the performance and the accuracy or a behavior. So here accuracy, precision, repeatability, efficiency, all these parameters will come into a capability model. So one important thing what we need to understand here, the reference ontology, it can be reused model. Okay, it can be used for any specific application. Like this closed loop system can be used in paint filling system, chemical dosing, CNC coolant control, robot dispensing, and it is not tied to a specific hardware. So the reference ontology is not tied to a specific hardware. This is a generalized model, a reusable model, which can be suited for any applications. In application ontology, we are going to apply the reference ontology into a specific application. That is an application ontology. So if you look at the system is automatic bottle filling system that detects a bottle, fills the liquid, and control the entire filling operation. So this ontology divided into different models to organize the system knowledge efficiently. So first we will see the basic concept model. The basic concept model defines the main entities or components present in this system. So in the bottle filling system, the basic components includes like a proximity sensor, level sensor, PLC, solenoid valve, conveyor belt, filling nozzle, and bottle. So these components represents a core element of the automation system. Now coming to the relationship model. In relationship model, this model explains next is the functional model. The functional model defines what the system does. In the bottle filling system, the major functions are bottle reduction, bottle positioning, like a liquid filling, conveyor movement, flow control, and system monitoring. There are many functions are included in the automation system. So these function describes the operation performed by the automation system. The last one is the capability model. The capability model defines how well the system performs its operation. So it basically represents the performance characteristics of the system. Okay, so first one is the filling accuracy. The accuracy we need to maintain for this automation system is plus or minus 2 ml. Then filling time should be 4 seconds and throughput will be 30 bottles per minute, and efficiency of the system can be 95%. So these capabilities determines the quality and efficiency of this automation process. So when all the ontology models are combined, the basic concept model defines the components, and the relationship model connects the components, the functional model explains the system operation, and the capability model evaluate the system performance. So together they create a complete intelligent model of a automatic bottle filling system. So if you look at this reference ontology, I already mentioned the reference ontology contains only the reference system, like a sensor controller, whereas the application ontology is a specific component required for building a particular system for the suitable application. This is a better visualization to understand the reference ontology model and application ontology model for the bottle filling system. So in reference ontology model, it is a reference component like system, conveyor, or actuator, object and other things. Whereas in application ontology model, it all specific components. If you look at the picture, it has all the specific components like sensor, controller, and the valve, bottle filling nozzle and other things. So if you look at this difference between reference ontology and application ontology, in reference ontology all are in general terms or generic terms, and it is a reusable model for any application. So it defines basically a concept and the relationship between the various components. Whereas in application ontology, it's all look like a real components. It's all like real components we need to use for building a particular system for suitable application. It's a specific system and it is used for actual implementation. Now we have learned about the reference ontology and application ontology. So now we'll just test our understanding with a short quiz. So first is, what is the main purpose of reference ontology? Reference ontology basically used for defining a general concept and relationship. The answer is B. Then second question is, which ontology is designed for a specific application? Specific application in the sense that is used for a application ontology. Application ontology is basically used for making it for a specific application. Then third is, which one of the following belongs to the reference ontology? In reference ontology, we have to give a reference name, not a specific name, right? So answer is C, sensor. The fourth question, which component is an example of application ontology? Application means we have to give a specific component, right? So what's the specific component available in this option? It's a D, conveyor sorting gate, because actuator, controller and system, these are all the reference ontology. Conveyor sorting gate is a specific name used for a sorting application. Okay, so the sorting gate, conveyor sorting gate is the answer for fourth question. Coming to the fifth one, the reference ontology is mainly used for. The options are specific implementation, standard reusable knowledge, real-time monitoring only, and mechanical assembly. So which is the correct answer out of this four? Answer is B, because the reference ontology is a reusable knowledge. It's a standard reusable knowledge. All these three are considered the application ontology, but the reference ontology is basically a reusable knowledge. Coming to the sixth question, the application ontology focuses on. Options are general concept only, reusable relationship, problem specific implementation, and mathematical equation. So answer is problem specific implementation. It's a problem oriented approach. It's a problem specific implementation. So seventh question, in an automatic bottle filling system, the bottle sensor belongs to. So option for this, reference ontology only, application ontology, mathematical ontology, and cloud ontology. The answer is B, because the bottle filling system, the bottle sensor is a specific, it's a application specific name, so it suits for application ontology. Now coming to the eighth one, which statement is correct? A reference ontology is a system specific. Application ontology is reusable for all type of system. Reference ontology provides a common engineering concept. Both are unrelated. So what is the answer for this? The answer is C. The reference ontology provides a common engineering concept. Application ontology is not a reusable one. Reference ontology is a reusable format.